The next perspective is an important one. An independent consultant. And this guy is royalty in my book. He is getting recognized tomorrow. Please start making your way this way. He's getting recognized tomorrow as MVP in our industry because he has devoted much of his life to studying the causes and the consequences and the solutions associated with I&I. And there's nobody better. He doesn't like this name, but I give him a handle of Mr. I&I, and he just doesn't like it. But I love it. I think it's very appropriate. Will you please welcome George Kurz.
Thank you, ladies and gentlemen. Good afternoon. And if I had a hat, I would certainly tip it to Tony Khan. That's the kind of system I would really have fun working with and seeing the benefit that can be brought to a community. Don referred to me as a consultant, and I do consulting, but actually at this point in my life, I really more think of myself as a researcher. So I'd like to, this is not a deal to try to get business or anything like that. I'm more interested in your data and working on something to be able to learn something more that we can share together to try to advance this process. So that kind of brings me to the thought about what's the big deal with I&I. And maybe the fact that you're here shows that you are kind of wondering about this. But interestingly, apparently there's a lot of folks out there that don't think this is a big deal. And I don't know why I didn't get a, come on. There we go. Okay. We talk about I&I like it's really important. And I personally think it is. I want to be absolutely clear about that. But when we show our actions, the way we act, which I think sometimes is a bigger indicator, indicates that we don't think it's important. So I'm going to give kind of a little brief summary here of, I'll run through a summary of the things that we're going to touch on today. And that is this, how much I&I is actually out there. And I have some actual objective data that shows that there's a significant difference between perception versus the reality. And that information on the reality of what actual quantity is will come from a statewide study that I performed for the state of Tennessee and then extended for the state of North Carolina. To my knowledge, these are the only two states that have been 100% studied of actual numbers from every community that's ever been done by EPA, a state agency, or any company. So these are real numbers. These aren't my opinions or estimates. That's led me to conclude that I believe firmly that I&I is the #1 problem that we face in collection systems today. Based on the work that I did earlier in parts of my life of looking at the before and after results from doing sewer rehabilitation projects, I began seeing patterns of what worked and what didn't. And because of that, I worked out kind of a 10-step program approach of what was really critical to have in a program. Now, this session today really doesn't allow time to be able to go into the 10-step approach, so I'm going to boil it down for you: detect, target, rehab, and verify. And I'll go into those when we get to that part. The result, and you may wonder, well, why isn't this an assumption or a given that the rehab works? I contend that we're still dealing out there in municipalities and with engineers that really don't believe it. So I'm going to go into some actual data, and similar to what Tony presented, that it actually does work. You know, you can deny it, but data is out there that does work. So looking back at what people actually think. And what happened was in about 2014, I was doing this analysis of every system in the state of Tennessee. And I found that as I was doing it, I had to go back to actually every MPDS permit and its the application that a permittee would make to get the permit. And when I looked in there, I found that required that everybody had to put down the amount of I&I that they thought or measured or however they came up with it, but they had to have a number in there in order to be able to get their permit. And it was very interesting. I thought, well, let's find out what people think. And this graph that you see here is the percent I&I actually reported by applicants for the MPDS permit. There was like 243 systems that I was looking at the time. And when I looked at the aggregate, in other words, if you considered all the I&I that they reported, and as though that was all pouring into a big bucket all year, that meant that the aggregate was slightly over 20% of the flow in all the Tennessee systems was considered to have been clear water. In other words, have its origin from either infiltration or inflow. So this was the opinion of people who are applying for MPDS permits. So when I actually took their data, keep in mind, I used 365 days worth of data of rainfall, flow, and BOD, which that's another story in itself, of what was actually being measured by these people, and the I&I that was actually measured was 45%. Big difference. Now, something else I want to point to, because I want to look at these data just in a slightly different way in the next slide, is that the lowest point on the first graph here does not correspond to the same city on the second graph. In other words, I reoriented these lists of towns so that it would just flow from left to right, nice and easy. So let's take a look at this, a second look at this I&I variation. Again, the first slide or the first graph is what you already saw, but when I lined it up city by city, so that starting at the left, it's the same city that is on the lower slide. This varies all over the place. In other words, if somebody who had an original estimate of low I&I may have had near the top, and somebody who had a high estimate may have been somewhat lower. So this was variation all over. This suggests to me it was jumping all over the place. They really probably didn't know at all. So just kind of as a recap, it was the average I&I that was reported, aggregate, was a little over 20%. The number that I finally found, which was actually eventually used for the ASCE report card that year for the state of Tennessee, over more than twice that amount. That leads me to believe that most public agencies likely really didn't either know how to measure their own I&I, or hadn't even thought about it, or didn't want to think about it. Which is really kind of a sad thought in my mind. So I had an opportunity to extend this study from the 243 for the state of Tennessee. Then I was able to get a hold of an equivalent amount of data from the state of North Carolina, lumped that all together, and then I put out kind of a national challenge on LinkedIn. And I said, anybody who will send me a year's worth of data, I'll send you back a report. No cost, no strings attached. I won't bother you again. I'll answer your question if you call me about it or something like that. And of that, I only had 9 takers. 9 takers. Free data, free engineering. Shows you can't give anything away. But obviously, I've flunked marketing 101 really bad. Don is over here just laughing away. But anyway, I did get 9 people in other states to submit data, so I lumped them all together. So I had a total of 528 systems. And of that 528, the picture was still pretty much the same, that the median I&I was over 50%. Now, the gross average was slightly or somewhat less. So anyway, thinking about that, of all the different kinds of problems that a collection system operator has, they've got providing good service, they've got costs they've got to face, they've got overflows. Tony kind of went over a bunch of them. Robert went over a bunch today. But I feel like that the number one problem they're facing is I&I, leaking sewers. That's what it boils down to. I don't care whether it's infiltration or inflow. I mean, I care if I'm doing the analysis, but it's with really looking at the problem, that's what it is. And here we then see the kind of almost the same list: SSOs, backups, degrading treatment efficiency because plants get overloaded, wasting money, increased costs, movement, loss of bedding material, so then you eventually lose the pipe, and then pipe collapses. The bottom line here is that what a lot of people thought they could do was upsize the pipes and upsize the facilities, but this doesn't fix the original problem. And I had a very pointed example of that when I was doing the hand research, because when I did this study, I had to go back and I transcribed over 170,000 data points from hard copy papers into an electronic file. So I had to go through all this stuff at the various state offices. And when I was doing that, I found this overflow report for the town of Bell Buckle, which is about an hour and a half south of Nashville here in Middle Tennessee. And what was kind of neat, this jumped in my head because I recognized Bell Buckle. They were on the original Conklin report back in 1981. But what really jumped out at me was this note here that this overflow was being reported from the equalization basin, which had been built as the answer to take care of excess flow in the system. The Conklin report, when I dug it back out of my files, I'm a pack rat, had mentioned that this was a report that really had sent shockwaves through all the state regulatory agencies. And I was working for Bob Odette at the time in the state of Tennessee. And essentially that report was EPA's summary of that sewer rehabilitation wasn't working very well to accomplish I&I reduction. And this was a real shocker because the whole 201 program was really hinged on that basis of building treatment plants that were going to be able to operate efficiently. So looking at what does work, and this was foremost in my mind when I started getting into doing sewer rehabilitation for various companies and municipal agencies, primarily here in Middle Tennessee. And I saw things that worked and saw things that didn't, and compiled it finally into a 10-step program. I'm sorry, I didn't mean it to sound like Moses and 10 Commandments. It's just 10 recommendations, but they seem to work. And it's really too long to go into for this presentation, but it really comes down to 4 essentials. 1, detect. Got to detect the I&I, got to be able to quantify it, be able to say what you have. Secondly, target the right area. I would certainly underscore and echo Tony Khan's point about going after a basin rather than the old EPA approach of take the biggest leak first and then go to the second biggest leak, which can be jumping all over a system, and you won't see results for a long, long time. And I don't know why I did that. Oh, here we are. Then, of course, plan and conduct your rehabilitation correctly, and I'll have some thoughts about that. And then finally, verify that you got your result. And this is something that I think has gotten lost with a lot of engineering companies. The ones that are general engineering companies, they build the construct a building. Well, you have your plans and your specs, and you hire your contractor, and you build the building. At the end of the job, you got a building. Everybody's happy. Hopefully the building works, but you see what you have. Well, the thing is with sewer rehabilitation, it's not just a matter of putting the liner in or putting the grout in or installing various appurtenances. The goal is not just to get that, it's to get the performance of why you put it in the first place. And the performance in this case, in many cases, not all, because there's some times when it's for structural reasons, but it's to get that excess leakage out. Okay. So, detecting. I'd like to show you something that I think is a real simple tool for detecting baseline conditions. And the reason why I developed it was twofold. One is when I was handling all that 170,000 data points, I finally had to have a way to organize the information. And I just worked it out on a simple Excel spreadsheet approach. But the other reason that I began seeing that it might be valuable is countless times I've gone in to talk to an operator or even a mayor in some small town. They said, well, George, you talk a good game of golf, that's real interesting at what you're talking about, and we sometimes worry about it, but we simply don't have the money to either hire you or hire some engineer or really move forward on this, so we aren't doing anything. To me, that's a tragedy. Well, this tool, it's just, like I say, it's a simple Excel spreadsheet. I decide I'm going to make it free publicly. So I give it as a license to anybody who wants. And I say it's a license because I did copyright it for various reasons, but it's not to have any kind of strings on it, just to make sure my name stays on it. So I've made it publicly available. And that would apply to anybody here. If you contact me, I'll give it to you. Neat thing about it, it only takes 15 minutes to analyze a year's worth of data. And anybody can do it. It does not require an engineering degree, and any operator that's passed his operator exam can easily do it. And it's been picked up by the TDEC, Tennessee Department of Environment and Conservation, to actually evaluate rehab progress. And it's this really simple tool, because what happens is you can see that as rainfall increases, it's a pretty much a straight line relationship, which is what has been published for years. And that the relationship as you get a larger 24-hour storm, you're going to get more RDII, rainfall dependent I&I. So it gives us a means to actually let you know where you stand. Now, thinking about selecting the target area, and emphasis on the word area. As Tony pointed out, I'm an advocate of picking a basin area rather than simply a single line or a single defect. That's the worst kind of situation. You've got to stop migration. In this case, it shows an area in the town of Brentwood, which is a satellite community to Nashville, where we are today. Satellite meaning that they don't have a treatment plant. They just pump it over to Nashville's treatment plant. And it turned out that this area, E11, up in the north side of Brentwood, was one of the worst areas I've ever seen in my professional life. But we used all the standard criteria, looking at overflows, we annual I&I, their peak hour I&I, and the overall condition as some of the main things to look at. But the point I want to make is pick the area which is your top priority area and knock it out. That's to stop migration. And then it's also kind of like the idea of eating an elephant. You eat it one part at a time. Once that area is gone, then you can work on the rest of the system. So looking at the rehab essentials, I advocate, and I think it was very similar to what Tony was talking about, a system approach. And that is looking at the pipes, manholes, and service laterals. He likes to do them staggered. That's fine. I like to do it all as one project. I assume that it's kind of like a what was that path effect in calculus that we learned years ago, which I've mostly forgotten, and it's still going to arrive at the same endpoint if you do all the steps. But one other point I'd like to make is the idea of connecting the dots, and that is you may find a segment that's got a lot of defects and a segment 2 segments down that's got some more defects, but the intervening segment really didn't look all that bad. They say, well, why do anything about that? Well, let's think about it. It was usually in the same kind of topography. It was built by the same crew, same materials, same age. It just maybe, in my view, it probably just hasn't quite reached that point where it's going to start showing defects yet. Why not get it while you're there? And this was one of the major lessons that I got when I developed that 10-step approach, because we began seeing that kind of pattern. If we fixed all the stuff that we saw and we didn't do the connect the dots, we started seeing more rapid deterioration in those connecting segments. Verifying effectiveness. Sure, it costs some money to go back and do some flow monitoring again, but to me, this is gold. And this is an example in that worst area there in Brentwood, E11. The blue line, which is the upper line, and by the way, the dotted lines on each side of these two solid lines, what that represents is a 95% confidence interval. Now, from an engineering standpoint, the way I was taught as an engineer, you never can really be absolutely certain about the absolute value of a particular measurement. It always has a plus minus value on it. And I think for design purposes, it's important to show that, because these are all statistically based types of analyses. But anyway, in this case, the data was pretty darn tight. And you can see that we got a very nice reduction there in that E11 area. And the fact that it's the final result for the 4.5 inches, that represents essentially the 5-year storm here in the Middle Tennessee area. That now that endpoint for the 5-year storm is below the capacity for that piece of line, or for that flow monitoring area. So now we have achieved containment, at least. We maybe not have achieved as much I&I reduction as we could, but we've got containment so that we're not going to be risking overflows. So a couple other measures to verify, just just about 3 slides left here. One is going from 2008 of just the annual hydrograph for that area. The annual INI calculated for 2008 for the Brentwood system, this is for the whole system, was about 46%. When we pretty much wrapped up the program there in 2014, they still have some work going on. The annual INI was slightly over half of that. Actually, they got out about 800 million gallons a year of clear water removed from that system. They still have a ways to go. Looking at the RDII reduction, the 5-year RDI projected out to about 10.7 million gallons in a 24-hour period. Now that's not the base flow; that's just the strictly related to the rainfall. By 2014, it had been knocked off about 2 million gallons, which got it quite close to containment. It wasn't absolutely there, but it's pretty much close to the capacity of the treatment plant. The final one I'll show you is a conglomeration of the results from all 29 project areas that we measured in Nashville and in Brentwood. My policy is I don't like to see a line across a graph where you don't see the data points. I kind of have a thing about that. I want to show the good, bad, and the ugly, and you've got it here. You can see some of those project areas didn't get, by our measurement, any INI reduction. And to be fair, some were installed primarily for structural reasons, so they weren't going to show any. But the one I'm pretty proud of is the one that you see right up there near the top of the graph. It's right close to the D in Brentwood. And that project was conducted using rigorously all 10 steps of the 10-step plan that I mentioned earlier, and did the before and after reduction. However, for all the calculations that I use as far as cost savings in Tennessee, I use the dotted line that's shown there, which is building in a safety factor, and which kind of handicaps the situation, but it keeps us from overestimating. In closing, I would never have been able to do this work of the statewide study without a great deal of assistance from people in all 7 of the basin offices across the state, and helping gather and collate these MOR reports. I still had to do the transcription, but they were really of great assistance. Also, just for recognition to Ken Carey and the Sacramento State courses where I source the little figures. So with that, questions?
Very impressed.
We are.
Thank you.
George, how long did it take you to build your spreadsheet? Because that looks, and are you getting great attention to that? Are people picking up the usage of that spreadsheet that you've developed?
Thank you for the question. Are people picking up on the spreadsheet? I'm very happy to say that the state of Tennessee has. You know, I've negotiated and discussed this with the state a lot, and I handed over the results, all the raw numbers and the final reports to the state of Tennessee. And some people, this bothers them. I've run into situations where communities think this is top secret. I don't know how it happens, but and I'd rather not speculate on some of the more negative aspects of might be implications there. But I turned it all over to the state with the idea that how can we possibly achieve any progress in understanding our problem and working out a strategy to correct it if we don't know what the nature and the extent and the quantity of the problem to start with. I used to be a military intelligence analyst, and I specialized in Soviet East Europe. It's part of my job was counting missiles, and I don't know any other way to go about this. So that's why I turned to the state. But as far as people who have taken me up on the LinkedIn request, very few. And truly, there are no strings attached. I've tried to make it very clear, but I will run it for anybody. And to me, the benefit is I get the data. As I said, I'm a researcher. I'm really interested in trying to define this as far as we can across all of North America. That's both in the U.S. and in Canada. I've gotten some data from Canada I've analyzed. Yes, and I'll be glad to send it to you. I really, the first paper I gave on that was the question was, where can we find the full 10 steps? I gave a paper on this in 1994. I've referred to it numerous times in other presentations. Actually, there was a series of seminars that was given here at UCT on an annual basis, and it was the idea of everything I ever learned about I&I in one package, but I'll be delighted to share it with you if you leave me a card, or I'll leave you a card or whatever. The question is asking for my impression of how the state looks at the basin type of approach, similar to Naperville. I don't have a good answer to that. I think they're still in a mode, for the most part, of doing the measurement, figuring out who should be on a moratorium, who, if they're going to give moratorium relief on a whole system. However, the good news is that the next speaker is Bob Odette from TDEC, and I think probably the best thing would be to ask Bob. I'm not trying to dodge you, but he can answer you much more directly than I can. So. Yeah, but I think he'll welcome it. He'll welcome it. Thank you. Yeah.